Hello? Hello there. Hey, can you hear me? Hey, can you hear me? Can you hear me? No, it should work now. Let me see now. Can you hear me? No, it should work now. Let me see. Yeah, it definitely works fine. So yeah. Pop up the chat and yep. Here we go. So hello everybody. Let's go for terminal. Keep it terminal, right? So yeah, hello everybody, and welcome to the stream. Let's wait until maybe someone will comment now in the first few minutes. No, it actually never happens. So yeah, we have serial eyes. Yeah, but since it's an HPP only, it will be declaration file only. So we won't do any stuff here actually. Yeah, again, we're currently looking forward to implement the algorithm, which is, well, the synchronization algorithm for Tetroflow, the new modern, similar to Redis actually, in-memory storage, but it will work a bit differently. So the sync itself, there won't be any big servers with single points of failure. We'll be relying on creating on local instances, like it's for example, like I think RabbitMQ does something similar. So like one of my colleagues said, well, it's at the back, it's like Apache Cassandra, but with a RabbitMQ visage, and I basically told yes. So we'll binding like directly to Unix sockets, and the main thing here is we want the user of the software will just be binding to well, as I mentioned, Unix sockets locally, and the whole binding will be done locally, obviously, so we don't have any security concerns, because implementing the cryptography, implementing all these key exchanges, etc., to keep it really secure, doesn't really make sense in this case, because again, yeah, why should it be used remotely, kind of. And on synchronization, we'll say, yeah, you better don't care about it, we'll do it ourselves, the whole synchronization stuff, right? So I was wondering what is the max amount of keys, or max amount of data which can be stored by Redis. And again, I will maybe make it backwards compatible with Redis. Yeah, right. So yeah, but again, it's something for later. Let's save it for later. So yeah, and what I'm looking forward to do is actually it will be dedicated, it will be specialized for horizontal scaling, especially. So the basically you include it into your, for example, Zabbix container. And when a Zabbix container starts, it automatically starts also a new Tetroflow instance and syncs the whole data and joins the cluster. And it automatically joins the cluster with, you can basically run just one Tetroflow, main Tetroflow instance. And there you basically define all the main or two main Tetroflow instances whatsoever. There's no such thing as the actually the main instance. So there's a static instance which is persistent, which is always there, and then you have basically some amount of and then you have a Zabbix, for example, container composed, which is with a also with Tetroflow in it, and the Tetroflow on Zabbix container is configured to instantly start, and there's only the address of this so to say persistent node there, and on starting it queries the persistent node. It tells, hello, here I am, I'm a new node, could you maybe send me the addresses, the IP addresses of the other nodes? And the persistent node basically tells it, well, here you are, here are all the addresses, and you have more persistent nodes. Well, it will be well, as I mentioned, synced, and if one new node appears, then all other nodes know about it. And if, for example, we start 10 Zabbix containers, they will not only communicate through the persistent node, but with each other directly. So even if the persistent node fails and instantly comes online, or a backup comes online, or whatever, nothing will be stopped. The data will be in the cluster persistently again, right? So you can basically easily turn off and turn on instances without it without the cluster being overloaded with the whole stuff. Because like normally, if you, for example, I think if you drop a Postgres node or Cassandra node, since the data is kind of distributed, you have to the rerouting process has to be started, etc. So yeah, it can be a bit more complicated in this case if all the data is consistent, and it's basically repeated all the time, and it's stored everywhere. It's just synced. Yeah, so that will be much easier, I think. Yeah, so again, we join cluster message and serialize public. Yeah, private cluster. Well, let's keep it in a shared pointer. Sticky. Oh, I have to import it, right? Yeah. Cluster. Node CTP. Yeah. Oops. Yeah. Right. We obviously can't just include the CTP class. Shared pointer. Yeah, this node, right? So yeah, we have the join cluster message, and we have this node pointing to the, obviously, yeah, the cluster node here is basically also itself. So yeah, so last heartbeat cluster node ID. Yes, So message. Yeah. So let's define it. Oh yeah, we have to use the constructor. Join cluster message. Yeah, and it should take also the struggle, which is purely optional, but yeah. Join cluster message. Yes, so it basically notifies. So it basically notifies. It's the yeah. Well, I have an idea actually. I have an idea. You could yeah, you could actually set the join cluster message. We don't actually need a join cluster message itself. We have to send a node notification message. Where I'm telling what node I am at, on what IP I'm running. Yeah, hell yeah. Yeah, I think it's even better. So cluster node. Let's take next heartbeat. Well, I have to do some string serialization here. CPP. String IP and 60 port. Shit. I really fucking hate it. I'm sorry. Sorry guys. But I really hate it. Like the whole serialization stuff by itself is just a nonsense, I think. Like define some let's make it right. So instead of joint cluster message, let's call it a define node notify. Let's call it notify cluster message. Notify cluster message. Yeah. Well. Notify cluster message. So we're basically notifying it that hello there, I'm here. All right, everybody, which is and the message will be basically broadcasted further, right? So yeah, it will be broadcasted further, and all the nodes they'll be basically checking the all the nodes will be checking their state and tell, all right, I haven't known you're here, I didn't knew you're here, so let's add you to the nodes list, and if something happens, we know we can sync data with you. right? So yeah, and this is what will happen. Let's put the message. Yeah, it's basically an empty constructor. So yeah, that's also fine. Oh, yeah. Message utils, message types. What I need it for now. Notify clusters 1. So what we need to serialize is basically telling about the node itself. So what do we need? It's the cluster node ID, IP and port. Cluster node ID, it's IP and port, right? Packet over pet. Okay, format. P cluster node ID, cluster node state. Obviously, we don't have to send it, but yeah, let's do it. Fuck it, let's do it. Cluster node ID state, then IP and port. So cluster node ID. Yeah. Huh. Let's see. It's unsigned, is it? Yeah, unsigned and 64D. Yeah, let's keep it like that. Right. With IP. Yeah, so we have it. We have it right here, right? So yeah. So now the packet's being serialized. It will be a cluster message. Serialized and deserialized. So we have to not deserialize. So IP is inaccessible. Oh, so this is the shit. Although I would actually do it the other way around. int. Yeah, I'm good with offsets. Should work. That should actually work fine. Although there's no such constructor. I hope it works. Yeah, obviously. Yeah. So I think we should go ahead and test it. I think we should go ahead and just test it. So we'll collapse the real main. Nope. Oh yeah, it's telling me to call the automated. Okay, right. Now let's include the cluster node. Let's include the no, I don't have a cluster manager for now, at least. But let's suggest. Yeah, that should work. Zero, blah blah blah. It's live. Let's see if it throws an error or not. It shouldn't. Yeah, it does not. Alright. And we X. Yep. Let's see. Open anyway. No. Oh. Although it does work. We have some length, which is obviously 64 bytes, 0000, an IP address. We have an IP address, right? And read mode. Okay, let's make it. Message. Screen. Join. Yep, something like that. I mean, it's by far not the best. It's by far not the best solution, but oh yeah, of course. Right. Actually, I shouldn't. Maybe I should do it as a without node. Yeah, see? That's the problem. Oh, no, it isn't. Yeah. So sometimes updating the header files, like storing data in header files only, is not the best solution because, yeah, it is not the best solution because it's not the best solution because the running make, I think it only checks the CPP files, and if you have some functionality in header files, it yeah, it tells there's nothing to compile, so you have to make clean and rebuild the whole stuff, and with so many, well, these aren't many files, but yeah, imagine, well, the project obviously grows, but yeah, it isn't always the best option, you know, to have kind of that many to all you know, to always like rebuild the whole stuff, the whole project. So yeah, let me remove it. So just it's by itself. Oh. Yep, I'll just set it to the null finder, which isn't the best, but explicitly defaulted. Oh, oh, I should see this coming, right? GPP bullet. No, I mean, I want to make it explicit, and yeah, it's obviously just.
Was kann man mit 50 Cent pro Tag machen? Kinderleben retten. Wirklich mit 50 Cent?
Some damn advertisement. Or some charity or something. Oh. Yeah, so I kind of wait not. Hopefully I didn't mess it up. Warning anti-parentheses where examined the function information. Move parameters to does it work? way. I mean, shouldn't a constructor be kind of cold? Yeah, it still works. Yeah. Hey. Yeah, let's just remove it and just read from the I hate the normal pointers, but whatever. Yeah, fine. Hey, works just fine. So yeah, we have the binary code here. Some strange symbols UDF. Yeah, it works. It works just fine. It was just for testing purposes only, so yeah. But we should actually initialize the kind of self. So the node it's itself we have to initialize as well, I was just thinking now, wait, let me check, does the stream work? Well, I was just thinking now, the stream works. Yeah, there's this bidirectional stuff with TCP sockets, obviously, and since I'm sending my my current IP address in the port to connect with me, and I'm basically broadcasting it further. So I want them to connect to me as clients to the server and not vice versa. So I mean, I can. And the question is, what would be the best option? So requesting, so I either query the main node, the main, it's not real main node, but then, better say nodes I'm aware of what nodes they are connected to, and what kind of nodes they are, or I'm just sending the notify cluster message. I'm basically notifying the cluster, and then I'm just waiting till somebody connects to me. So these are two methods I could use. Oops, sorry. Music's gone. Yep, sorry. Something. Yes. God damn it, there's so much advertisement in YouTube nowadays. I'm really happy that I just purchased the YouTube Premium on my main account. Yeah, it is my main account, but yeah. Yeah. God fucking sake. I hate the advertisement. Yeah. Yeah, let's keep it the way. Or although, let's take my main. Let's take my main account and just log into ChatGPT. And yeah, unfortunately, I cannot tell you what I see, because again there are some questions also related to some proprietary stuff I'm working on. So let's question it. I'm working on a mechanism to automatically build a cluster and mesh network for a database application which is ouch. So is should I decide to do? Check the oh yeah. Let's also ask the co-pilot. Maybe you could suggest something. Maybe you could suggest something. contact seed nodes to get the list of active nodes, register service, start gossiping with other nodes, right? Yeah, that's nearly what I wanted to do actually. Query the source for the seed of the nodes for the list of active nodes. Okay, establish connect, blah blah. It's just blah blah blah, right? Because protocol, mutex. Oh, this thing already analyzed the code base, and it knows how I'm using the mutex, I'm defining the mutex, etc. Right, it's good. Contact, seed nodes, gossip protocol, gossiping with nodes. Right, contact seed nodes, thread gossip thread join. Yeah, alright. Didn't tell me much, but let's see what ChatGPT has so far. Seed nodes Cassandra uses seed nodes as initial contact point, noding the cluster, knowing the nodes contacted the node, get the full list of the node cluster. Seed nodes don't necessarily act as fixed server, they simply provide the state of the cluster, allowing the new nodes to initiate the connection with the other nodes, right? Especially this clustering allows nodes to connect to each other directly via central OR, via central broker. For dynamic clusters, common to integrate specific nodes to track state and show connection information, right? So basically, yeah, everyone's using just the so-called seed nodes, as I get it. I mean, I haven't heard it before, like more of a like just main nodes, but I guess. Yeah, I guess the calling it the seed nodes just makes sense. Yeah, it makes a lot of sense. It makes a lot of sense. So what else? Protocol, each node's protocol shares information with a small, so not with every node, but with a small subset of node, right? Ensuring that the entire cluster eventually has a consistent view of which nodes are up or down. This way, a new node can broadcast its presence without requiring a direct connection with every other node. Okay. Client server mode for regular similar systems. You often establish clients or like mode where nodes connect to a server, receive the node list, and form measured or direct connections. But again, you cannot. There is no such thing. No, in this case, no such thing as a really direct P2P connection. There is always a server which is listening and a client which connects and is being listened. So, I mean, it would be just easy to. What I would actually love to do is to basically have the two servers, right? I specify the port of one server. This is well specific ports, so a port of one server, and the same specific port and IP and port of the other server, and I just press both and connect, and well, they are just connecting, and they can just like establish the connection. But I mean, I know how networks work, right? That's why I'm going to the university. Okay, so yeah, it technically it doesn't make much sense to do such thing, but it would be much easier for some cases. Answer a model for dynamic clustering for everything your similar systems. You often establish a client server-like model where nodes connect to. Yeah. Approach, sending a message to no nodes, on your approach options. So yeah, that's exactly what I wrote. But what are the pros and cons? Which is the present whether you persistent nodes, which can inform the other nodes about the new entrant. This approach minimizes the burden on each new node, making it primarily a client until it's established all the connections. Well, but I don't really care in this case. No listen, but alternatively, each new node could retrieve a list of active nodes from a seed node and initiate the connections directly. It minimizes the load on persistent node, but increases the responsibility on the joining node. Right. So I think this is that's the stuff I'm going to go with. So it's very important that the main, like, quote main, like balancer nodes, or the seed nodes as they call them here, they're loaded, but it's important to keep them just as unloaded as possible, right? So yeah, giving just focus on specific and dynamic changes using block methods in combination would be effective. The node contact seed node for initial list of known nodes, broadcast to persistence. Oh, I mean, they will be sending them. Broadcast to presence establish themselves quickly. Rely on a light gossip mechanism or heartbeat messages to keep all nodes updated. Yep. So yeah, it will be just the node information will be a shit. Yeah, wait a second. So how does so the node goes to the server and opens a connection where it's telling about itself. The node goes to the other node and is telling about itself. What am I? What kind of? Yeah. What am I? Just that's it. Hello. I'm here. I'm online. What do I have to do? Yeah. That would be the best option, I guess. Yeah. So and then the other node registers the node and tells hello. These are the nodes I have. But then there is another problem I figured out. Then not all nodes know about that new node. Not all nodes do know about the node, right? But, well, wait a second. On the other hand, yeah, I'm sorry for that for not coding, but yeah, again, I have to think now. I really have to think it through. Let me think. But if a new node which gets all the connections from the from the seed node, if it establishes all the connections to all the other nodes, all the other nodes will know that this node exists, right? All the other nodes can then, if some node topology desync happens, all the other nodes can basically notify the new node whether yeah, whether it's connected or not. So yeah, so whether the nodes are connected or no or not, and if some other nodes are connected there, which our current node isn't aware of, it will be known to the node and the connection will be established further. So everyone is knowing of everyone, knows about everyone. Yeah, that's, I think, I mean, it can be complicated, and the the notifying all the other nodes will be much simpler. So packet wise, but what the hell? No, we can just I was thinking about serializing the whole. So basically, there's a node we have to serialize, right? And send it. And now we have a whole fucking array of nodes we have to serialize. So we have to serialize the array itself, how long it is, and then the all the nodes by themselves with all the length with all the lengths, all the offsets, etc. But I'm just thinking, no, we can just notify cluster message notify. I mean, would have called it notify node message. So the node is being notified of other nodes. The hell, but we have to. Yeah, we have to create it. So every message has int 64t. Oh yeah. Has a d. It has a timestamp. The hell, it repeats the data. Actually, never. Yeah, it works. So, just repeating the data. Sender. Yeah, let's include the current sender node. Receiver. We don't actually have any of the receivers. Most of the time, we're just broadcasting it even further and further. So yeah. But I think in gossip we won't be in gossip we won't be just sending the data to some nodes. Instead, we'll be just yeah, just sending it to everyone and yeah, for receiver and abstract and yep, that's the message. Yeah, so we have some longs here. The packet's gonna be pretty long, but yes. Great network message. Data. No, it's STD. STD. Data. network message. Yeah. Center ID. Yep. We don't even actually need the length here, so we're basically calculating the length. Maybe we also have to calculate some checksum. Oh yeah, obviously. 8-bit type. 60T. Checksum. Move it upper. So center. Yup. We have to include type message. HTTP. Right. Message type. Length. Message type. And STD vector bytes data. Right. Yeah. That should be just fine. Oh, someone joined. Hello there. Yeah. So now we should actually create some kind of small algorithm for calculating the checksum. I mean, we could technically move to the just longs, but I just actually want to keep the packet size as small as possible, right? Just wanna, yeah. Hopefully checksum. Yeah, let's just return 0 for now, but fix me implement the checksum calculation, right? And message, yeah. Yeah, it works just fine. The checksum calculation. So the network message data. ID. The ID is gonna be obviously random. Then the timestamp. Yeah, I think I have the details right. unique timestamp. Yeah, unique timestamp. Then the center. Yeah, do we actually really need the sender? Do we need the sender? Yeah, I would include it actually. Right, so let's go to the notify cluster message and create some extra stuff here. It would be oh yeah, we have to actually serialize it. Right, I just like forgot it. It would have been a mess. So we're basically filling up this stuff and shit. I nearly used the real pointer here. No fucking real pointers. The shared pointers. Yeah, no, it's fine. No, it's fine. Yep. Notify cluster message. Notify cluster message. I think we have to kind of rename it. Come on. Node 8. Node info message. Here, and whatever. Just replace it. I don't like this music. Yep, it's much better. Nope. Node message. Yep. Realize. Message. Network. So we have to create a network message for that. message.hpp. So yeah, experiment parameters will have an ID. Oh yeah, we also have to, hello there. We have to use we have the message utils already completed. So we have to message utils.hpp. We have to connect them, and we have functions like generate unique ID, which is just a random function, but since it's 64 bits, yeah. Wait a second. Yep. Unit 64T, generate unique. Okay. Nope. No, not ready. No, nothing. You're telling me it's just the same, right? Pocket. Oh, sorry. I'm not allowed to. No. So yeah, here it is, and here we have this stuff, and here the first parameter gets is the ID. So basically, you can generate unique ID, generate unique timestamp. The standards at the center is 0 for now. I mean, this function is way too overkill long, so I'll just split it a bit. Yeah, I know. I kind of I don't like this function splitting myself. I want to have everything in line, but this case, yeah. So the network's message there, and ST let's serialize it. So oh, it's already there. Right? Something's odd. It can't work. It kind of I have kind of this feeling, the pain in the ass feeling. Create network message. So we just created the network message, right? Create network message. We have here network message here. Unique ID. There's this timestamp. Use sender, right? Right. So we're copying the data, and it returns us the well. Oh, that although it should work. Yeah, there's some. It should definitely work. I'll make it a bit smaller. Sorry, guys, if it becomes a kind of bit unreal, but I cannot, unfortunately, yeah, do something. I mean I can, but it's way too large for me, you know, especially on a big monitor, on a big screen, right? So yeah, we're converting not even message into bytes. So that's it. And now we have Message. Message. Oh, well, it can be complicated, but it's not actually well. Yeah, I like working with offsets. Offset. Oh yeah, we have to do the yeah, that works. That hopefully, at least hopefully, turn a message. So yeah, instead of like returning the null pointer, which everyone would have done, at least according to the AI, and since the Copilot is just it's a bare approximator, which just takes the average case, analyzes my code, and gets the average case from the basically GitHub. So many people would have done it, just return the null pointer. But no, if just anything's happening, I'm just throwing an error. Checks in this case, yeah, it checked. To work. Okay. Payload checks on mismatch. But in this case, it won't be a problem. So yeah, because we haven't implemented it, it's just a 0. So let's make it and see if yeah. Oh, it's string. Syntax. Where's the memcpy? Oh, it's not here. It's in the message. Yeah. Message. Oh yeah. Yeah, and just return the bytes. Nearly forgot just to yeah, it would be silly. But yeah. So yeah, and then we'll have to create a kind of a caster, which detects what type of which gets the network packets and on using like just normal key switch condition, it checks whether the yeah whether the code is the package is first of all legit, and second of all whether the package is yeah what kind of package it is. So it can basically return the then the object with a more C++ object oriented stuff, inheritance, etc. But for now, we'll leave it like that because yeah. I mean, yeah, the communication will the JSON communication will on the one hand much simpler, but on the other hand, come on, all the yeah, it doesn't it kind of doesn't feel professional, you know. So yeah, it doesn't feel professional. So no info message. Yeah, let's move to the pseudo global again. Oh, no info message, network message, utils. Right. So um, let's let's yeah let's just define something, some data, whatever. Oh. Uh, message. No. So yeah, with this thing we don't have to make all the extra stuff. We just cast the it's all the extra stuff, all the functions are hidden behind the node info message to bytes. It's node message to bytes. Print. Let's take a look at them. So I know whether it's legit or not. I really can't read the is there numbers? Did you really check someone? Yeah, I guess. Yeah. What to a binary file as yeah. Actually, it's much simpler than the just the STD with the file etc. But the STD works on both platforms, and in this case, I think it's just it's just POSIX. Huh? No fucking way it works. No, 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 it's impossible. It's just some cute. No, it's impossible. Maybe the element size element output. Huh? It just oops, can't be true. It just can't. It just can't. Oh. Yeah, it's there's no way it works. I have a kind of gut feeling. I don't know how to explain it, but maybe use the, instead of character, use the yeah, actually no way. I want to move from this like data types. Right. So yeah, that's exactly the gut feeling I had, right? Mhm. Serialize. Let's use the offset. Nine. Yeah, yeah, I know the data should be actually growing, so uh, the smallest units should be at the beginning, but it's kind of vice versa here. And then the data pushing back yeah, it's just pushing back the byte. But no. If to test spin bytes. No, it's a bullshit. Yeah, yeah, I thought it's. Yep, that's the bin. Bytes. Let's pilot, let's make it. And yeah, like the song, it feels right. But in this case, it really feels like right. Or the data is here. Everything's here. Yeah, a bunch of zeros. So this is basically the node existence package, which obviously identifies that the node exists. Going along here. It's telling me hello, I am right here. Yeah, oh, someone joined. Hello there. Yeah, So this serialization protocol, yeah, it works. So we can serialize the the node information packages, right? TNT tourist. Hello? But what's a TNT tourist? Yeah, so it works. We can check we have to check the deserialization now. Yeah. So, message, does it work? Message types. But if everything, no, I won't be able to deserialize it directly to the info message because there is no switch case here, which detects what kind of package there is, but I will be able to serialize it to the normal network message though, which isn't, oh, I have to do it accessible from the bytes. Oh, yeah. Fuck. STD vector, STD. Right. Yep. With the offset, right. Ave Copilot, thank you. Otherwise, I should have written it all by myself, which I just don't want to. Message from bytes, which is, I have to declare it in the header file. So what is a TNT tourist? Nope. Oh, yeah. Zero checksum 0. Yeah, it seems to work fine. Yeah, but again, I have to statement the function to deserialize it, which I think we could do it in network. We can do it in message utils or in network. Let's do it in network message itself. So std should return an std point to the it should return a let's see this message. We're getting bytes here. No, we're getting E. We're getting E. No pointer to the network message. Yep, but since it's pre-deserialized, we can. Yep. Nope. Switch meh. Vector master. So std vector from bytes message data. Huh? No, because the data itself is already in from message data, or it's called whatever it's called, like. Oh, yeah, that's a mess, obviously. Yeah. So you're right. Unknown message type. So now we see a message. Otherwise, with a row and error here. So declare the header file and yep. Pointer node info message. No, it's not a it's just message. It's just message. It's a bullshit. Yeah, I know. I'm talking with a bit German accent. I know. Bullshit. Serialize the message. Yeah. Message. I just want message. Any message as a parent type for. Yeah. So is it parent type? This is a parent type. Or message from bytes. Message type slash no info message.hpp and yeah, it's the message, not message info from bytes. Let's go from raw bytes, because there is the obvious bytes which I'm using, which is the std byte, and but in this case from raw bytes, and this case these aren't raw bytes. So these are, I think, yeah, since it is an std, it's a wrapper around it, but from raw bytes in length. I mean, is it necessary to provide the length? Yeah, I guess. I could try, since it's when it's being transported locally, I can rely that the last character of the robot just doesn't point anywhere else. So because because how it works. So basically, a character with a with a with a star here. It's a character. It's yeah. It's 126 bytes. I think. Yeah, it's 127 bytes. Stuff or 200 whatever. I forgot. I'm sorry. I didn't learn for that exam where to specify all the data types, etc. So I don't know it now. Yeah, should have learned better. Right. So message. Oh, bytes. Yeah. Binding file. Yeah, let's copy it just like over there. So some 2 or 3 people or whatever, how many joined and simply left. Well, it's sad. Create a message and return a message. Right, so it should be just fine. Here, everything's fine, everything's fine. Message, yes, what? Let's make it. Let's see. Seems to work, but seems to work by far doesn't mean that it does. So, no info message. Oh, so it was the dynamic acid, in fact, right? Because actually, it shouldn't be. In this case, I shouldn't use it. Oh, whoa! It worked just fine. Okay, let's remove the part with the file. Yeah, file. Yeah, it works. Let's commit changes. Start. Let's basic serial indexation and serial indexation over and with the yep. Yeah, so yeah, we should find a way to build the network topology. Now we have to find a way to start building the network topology for the basically a mesh network here for the sync. Let me think. Yeah, let's continue. So yeah, we have a mechanism to tell about ourselves, or to tell about like anything. Yeah, but I think I will unfortunately have to finish the stream a bit earlier, cause yeah, I have to go buy groceries now, cause I haven't eaten in the whole fucking day. So yeah, yeah, it's yeah. Otherwise the shops would close. So yeah, yeah. So thanks for watching. And yeah, see